All right, folks, now welcome back. Now what we have here, we have a 30-gallon electric water heater. For the purpose of this demonstration, we're going to stick to electric. I know some of you probably have a gas water heater, but that definitely should be addressed by a professional. The electric's a little bit different. A lot of this you can do at home. First off, what we're going to cover some basic parts and operation of the heater. Anytime you're dealing with the water heater, the first thing you want to do, look for the data plate. Whether it's on the side, the top, somewhere is going to give you the information about this heater. That is key for sizing of your elements and the amount of voltage that's actually going to be going into the unit. Dan, you want to just run us through the parts real quick?
And the size of the tank. Basically, this up here is called a T&P, a temperature and pressure relief valve. It relieves the pressure if it gets over 125, and it relieves the water if it goes over 160. And this is the upper thermostat, and this is the lower thermostat, and there's an element and an element. So this has two elements, two thermostats, and one T&P. Those are basically the working parts of the water heater.
This is a nice, pretty water heater, water heater element, 4,500 watt, brand new out of the pack. This is typical to any of today's 30, 40, 50-gallon heaters. Unless you have something special, this is probably what you're dealing with. Now, our two typical calls are we've had extremely hot water and now we have none, or we just can't get enough hot water. Dan, why don't you cover the first one? The water's got too hot.
Okay, when the water usually gets too hot and then you don't have any hot water, it's usually this thermostat up here. What happens is the water gets super hot because this thermostat's not shutting down when it's supposed to, and it gets too hot, it pops the reset button on there, so now it's not making any hot water.
And that temperature is 160 degrees, so that just lets you know how hot it got before this unit actually shut down. Typically what we tell you on the phone, reset your breaker. A lot of times what you're doing is you're actually tricking this into resetting itself. If that doesn't work, the next step you're going to want to do, obviously you're going to have to shut down the power. You're going to open the covers, remove the insulation, and definitely going to need to get you a voltage meter. Can't do nothing without a voltage meter. Typically you need to find one that's going to do higher than the voltage that you have. Mine does 300 because we're testing 240. If you have one that only does 200, you are taking the chance of the fuse in the back popping and lighting your butt up, so you don't want to do that. So what we're going to do now, first thing we're doing is we're checking for power. I've got it set for 300 volts. I'm going to take my two leads. I'm going to touch the top two wires. If I read anywhere from about 237 to a little over 240, we're good. There will be a little bit of a give and take. So that tells me I've got power. Next thing I'm going to do, I'm going to drop down to the next two bars right underneath of it. Boom. I'm going to test it there. Should have the same thing. If I don't, what that's telling me is exactly what we just talked about. The switch in here has actually been activated. It's killed the power to the unit. We're not getting hot water. You're going to have to replace the upper thermostat.
And when you replace the upper, you might as well replace the lower.
Anytime you do one, you might as well do both because you're already in the habit, you're already in the box. You replace this one goes out in a month, you're just going to make yourself mad.
Same thing for the elements. If you do one, it's better to do both of them.
Now the call where we get that we're running out of hot water, typically that's not related to a thermostat, that's usually something to do with an element. So what we're going to want to do is check out continuity on that element. So what I'm going to do, mine has an audible setting down on the ohms. I got it set on the audible, I should be able to hear a tone. Ideally, if it's got continuity, you hear an audible tone. So now I've removed the wire, power's off. I've removed the wire, any wire off the element, there's still one connected. I'm going to check it.
He has the beep, so he has continuity.
That it should be good.
It should be a good element.
Now there are some faults. We found along the way that sometimes you'll get that beep, but maybe the element's not actually good. So the second thing you want to check, leave one lead on, take your other lead to ground.
And you shouldn't get a beep. Should be infinity.
If you get a beep, that's telling you that the element's grounded out and it's bad. Same thing with this. You replace one, you might as well replace both. What the element looks like that's grounded out, and we're going to go ahead and we're going to pretend that we drain the water out. We recommend you always drain the water out. We typically can do them full. We've had years of practice.
And we read this one out, it doesn't give you an audible because this is the bad one. Something's the matter with this.
So we've got the wiring off, we got the water drain.
So we're looking at this and it's showing that it's open, infinity.
We've taken, now you will have to have a special tool. This is a 1.5 inch socket. I've got it hooked to a breaker bar. If you have an older heater, you're gonna wanna have some leverage to it. I purchased this socket from an auto parts store. It's actually an axle socket, so you can get them. You just lock it on there, flip the lever over, get yourself some leverage, break it apart. This particular element, that's exactly what we were talking about.
This is that element. You can see it burnt through right here.
If I tested that element, there's a good chance that there was enough here touching in that water that it would tell me that it had continuity. But if I would have ground checked that, it would have never worked. So we would replace both the upper and lower element. Anytime you're in the tank, if you go as far as getting to the elements, just replace everything in here because you're going to end up doing it at some point. You've already went through all the work of draining it. Just go ahead and get it out of the way. With the wiring for the thermostats themselves, typically when you open the pack, as Dan's showing you,
Comes with a wiring diagram right here.
your wiring diagram is right inside.
And you could use this to write down the color of the wires on the screws if it's a different color.
It is vital to make sure that as you diswire this, that you wire the other one properly in the same way, or you're either going to fry an element or it's just not going to work. So that's the biggest thing with them. Typically what they'll tell you if you have a new heater that you'd want to flush this, I think they told us in this particular model,
Couple quarts a month.
about a couple quarts a month out.
Some manufacturers say to drain the whole thing once a year. Some say a gallon a month. I do 5 gallons twice a year.
Now, if you have an older heater, you've never done it, it's over 4, 5, 6 years old, you got some pretty hard water, good idea is probably never to start because a lot of times what happens is the valve won't shut back down on you when you go to shut her down, or you're going to push sediment actually the wrong way, and you're going to be inside the house fighting to get all of the debris that you just pushed up in there cold out. We're always there. We're by the phone 24/7. Dan's actually in the office. You could ask for him by name. Any problems that you would have, you'd be more than welcome to call us. If you don't think you can tackle it yourself, if not, we're there for you.